Hello, hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I'm going to show you how you can classify a bank customer satisfaction prediction using a CNN and a feature selection. I'll be using a dataset from a Kaggle, which is Santander customer satisfaction dataset. And you see here you have a data this and you can download, otherwise you can directly import it from my GitHub repository. And this competition was run 3 years ago, and the people here at Kaggle in private leaderboard has attained a maximum accuracy of 82.90, but in a public leaderboard they have achieved maximum accuracy 84.53%. I'll be showing you how you can achieve a 96% of accuracy by doing a feature selections and applying a convolutional neural network into this dataset. So without wasting time, let's go ahead and start a step-by-step lesson into step-by-step lesson for a bank customer satisfaction prediction using a CNN and a feature selection. So in this lesson, we will be working on a Santander customer satisfaction dataset. It was a competition run at Kaggle.com, and it was worth of $60,000. More than 5,000 teams were participated in this competition, and the Santander was actually investigating how many their customers are happy with their bank or not. All right, so they have a lot of some other type of the customers, some were unhappy and some were happy. And before the customer wanted to leave their bank, they wanted to know whether their customer is happy or not. So the Santander Bank asked the Kagglers to help them identify how many customers are dissatisfied or whether they are gonna leave the bank or not. So they had provided a data set. You can go ahead and visit this link, a data set. So they have a train and the test data set. These are a CSV file, and each of these data set have more than 75,000 rows, and there are 370 columns. That means there are 370 features, and these features, all right, so these 370 features, there are so many features, and the data which actually they converted into the CSV file, those data were the name has been just converted. That's mean just they have given a v1 v2 v kind of, it's a kind of anonymous data, so the banker's name and other information or a personal information is not revealed. And with this leaderboard, you can see the accuracy which was achieved by the Kagglers, So there the maximum accuracy is achieved by 82.97%. Sorry, 82.90%. So this is the maximum accuracy achieved by the Kagglers in a private leaderboard, and in a public leaderboard it is 84.53%. So in these lessons, I'm going to show you how you can achieve an accuracy of more than 90% on this Santander dataset. So we will be implementing a convolutional neural network to detect whether customer is to predict whether customer is satisfied or not. But before applying a neural network, we will be also applying some feature selection techniques. And if you have seen my previous videos in which I have covered only feature selections in machine learning, it was around 6 hours of lectures, and it had 11 videos. There I have taught so many techniques of feature selections, and feature selections really helps you to identify most important features and reduce the machine learning model's complexity, and ultimately it increases accuracy and reduces the training time. All right, so this is all about the theory. Let's go ahead and start working on a Google Colab notebook. And if you don't know how to work on Google Colab notebook, you can go ahead at my channel KGP Talkie. You see here I have been making so many videos on a Google Colab. You can go ahead and visit these initial few videos. There I have taught how to work with Google Colab. All right, so otherwise you can go ahead and start the new Python 3 notebooks, and then after that you need to set here a runtime, which we are going to use here TPU, and then we need to install a GPU on the Google Colab notebook. So let's go ahead. The first install a GPU. Currently we have TensorFlow GPU 2.0 beta version. during this video recording. In future you might get the other version, so keep your eyes at tensorflow.org. there you will get latest version. Okay, so here we have a TensorFlow, and then we have GPU is equal to 2.0.0. then we have a release candidate 0, which is equivalent to a beta version of a TensorFlow GPU. Otherwise, alright, so it will take some time to install, and in meantime what we can do, we can wait for some time to get it installed. Alright, so TensorFlow GPU installation has been successfully done. Now let's go ahead and import TensorFlow and models as well as the TensorFlow layers to build our convolutional neural networks. So we are going to import here. We are going to first import the TensorFlow as TF, and after that I'm gonna import here a TensorFlow .keras. .keras. We are going to import here sequential layer first. All right, and after this sequential model, we should actually import from, from TensorFlow.keras import a sequential. All right, after that we need to import the layers from TensorFlow.keras. So let's go ahead and import TensorFlow.keras.layers, and then import. We need to import first convolutional 1D layer. So there we have a conv 1D, and after that we are going to import here a max pool 1D, and after that we are gonna import a flattening layer, and then finally we will be also needing a dense layer, and of course we will be needing a dropout to regularize our model, and we will be also needing batch normalization to make it a little more faster. Alright, so after this we will be also needing here some supporting libraries, but before that let's go ahead and print the TensorFlow version so that you can verify that which version you are actually using, so that we can say the tf dot version and print it. Alright, so we are using here 2.0.0 RC0, which is a beta version of TensorFlow 2.0. Let's go ahead and import supporting libraries like NumPy as NP, and we are also gonna import the pandas as PD, and apart from that we are also going to import a Seaborn as SNS. Alright, and apart from that we are also going to import matplotlib dot py plot as PLT. Alright, so here we have imported necessary libraries, and apart from that we will be also needing libraries from sklearn. So let's go ahead and import necessary libraries from sklearn as well. So from sklearn dot model selection import train test split. It will be used to divide our data set into training and the testing, and apart from that we need here sklearn dot pre-processing, actually import standard scaler, and apart from that we also need here sklearn dot feature selection, and then we need here a variance threshold. So we'll be also applying a filtering methods of a feature selection, and if you want to know more about the filtering methods of a feature selection, you can go ahead at my channel KGP Talkie. There I have a playlist feature selection in machine learning using a Python. The link of this video has been also given in the video description. There you can see the first few lessons where I have taught about the filtering methods, how you can remove a constant, quasi constant, and duplicate features, which we will be doing in this lesson. Alright, so with this what we get, we have imported all the necessary libraries. Now we are going to get the data. Alright, so you can download this data from here itself, and after the downloading you can upload this data here into a file. You see, if you have a file, you can upload it from your computer. Otherwise, I have also provided a GitHub link from where you can download this data. Alright, so we have here a Santander test.csv and santander.train.csv. So this is available at my GitHub link, and this link is also available in this notebook. I'm gonna add the link of this notebook, the dataset link. Alright, so you can download this, and the link for this notebook will be available into a video description. Now let's go ahead and from here you need to get this link. You can copy this and come here, then we need to call here git clone. So let's go ahead and call here git clone, and then we can paste our the GitHub link. Now with this, it will clone this repository here. Alright, that means you will get these data, the Santander test.csv and Santander train.csv. I haven't done anything in this data. I have just renamed it Santander test and Santander train data. Alright, so after this, once you have this data set, you can refresh this file and now you can get here our data set. So here we have a Santander test.csv and Santander the train.csv. Now let's go ahead and read this data. We can read this into a data variable by calling pandas data frame, pandas.pd.read_csv, and then it asks about the address from where it wants to read, and then we need Santander train.csv. There you can right click and get the path of this file, and you can place that path here. And apart from that, we are also going to print first few lines of this data set by calling data.head. It will print first 5 lines of a data, and once, let's go ahead and close this. We don't need that. It might take a little time to complete this processing. Just wait for a few seconds to get it complete. Alright, so it has been completed. It has a 5 row. Of course, I have just printed 5 row by calling this head. And then you see here it has a 371 columns. That's mean we have a huge feature space, a set of features, a huge number of features. And the first feature is a ID. And apart from that ID, you see here in the last it has a target, right? So this is the target. If 0 means the customer is not satisfied and 1 means the customer is satisfied. All right. So apart from this, let's go ahead and get the shape of this data. In fact, you can print now, but before that, let's go ahead and add few cells so that we can get some space, working space. So here we have a data.shape. And if you print data.shape, it says that we have a total 76,020 files. I mean 76,020 rows and 371 columns. Now let's go ahead and read the x vector. Here we have a x, that's mean a feature vector. A feature vector we can get with the data, and then we need to drop 2 columns here. The first column ID. ID of course will not play any role in prediction. This is just a customer ID. And then finally we need to also drop a target, because the target is a variable which we want to predict, so we cannot include that into feature space. And apart from that, x is equal to the data.drop, and then here we want to give the label's name which we want to drop inside a list, and there we want to actually drop, let's go ahead and see the label of first, that's the ID. And apart from the ID, we want to also drop a target, and this label will be made at is available at axis 1. That's when we need to provide here, drop these label from axis 1. And apart from that, let's go ahead and now see a shape of this data set. Now this has 76,020 and 369 features. All right, so let's go ahead and get y. So here y will be data and then target. So this is y, okay, which we want to predict whether customer is satisfied or not. All right, so let's go ahead and now call a train and the test split. Then after that we will start doing a feature selection technique. All right, so here we have x underscore train and then x underscore test, then y underscore train, and then similarly we have y underscore test is equal to Then we have a train test split, and there we have x, y, and then we have here a test size. All right, so we have a test size, I mean how much we want to put the test data, okay, from x. So that is the 0.2. That's mean the 20% data will be used as a testing data, and I'm also gonna set here a random state is equal to 0, so that you can also get a same output. And stratify is y. That's mean it will divide training and the testing data set symmetrically as per the label of y. All right, so with this you get here as the training and the testing data set. Let's go ahead and get the shape of the training and the testing data set. Now you see here 60,816 rows are into a training data set and 15,204 rows into a testing data set. All right, now we are going to remove add here, let's go ahead and add here, remove a constant. All right, so here we remove a constant, Quasi constant, and duplicate features. Why we want to remove a constant, Quasi constant, and duplicate features? You see the feature set is too large, right? So there are 369 features. There could be a very high chance of the feature duplication. For example, let's say if these two features are the duplicate, then either one of these features will not play an important role into final predictions. So if some features are a duplicate, then those features will definitely make your machine learning model a complex, and that will cause a overfit. And apart from that, if features are a constant, let's say if all these features are just a 0, all right, so if features are just a 0, then that is also not going to that is not also going to put any importance in a feature in a final prediction. And apart from that, why we want to remove the Quasi constant feature? For example, suppose that if these rows have just a single value 195 and all other values are 0, that's mean this column if doesn't have any variance, right? If any column doesn't have a variance, that's mean there is no information lies in that column. All right, so we need to remove those columns. So here we are going to remove constant, Quasi constant, and duplicate features. And if you want to know more about these, you can go ahead at my channel. There I have taught how you can remove a constant, Quasi constant, and duplicate features. And here I have a total full list of the codes for all these the techniques. So in the filtering methods, you will get that the constants and the Quasi constant removal, and you see here. All right, so after that you can go ahead and see here in the detail. There I have how removed the constant features, and then how I have removed so Quasi constants and the duplicate features. All right, okay, so here although I'm gonna implement this, how I'm going to remove this. So the filter is equal to a variance threshold so I'm gonna put here variance threshold 0.1. That's mean if any columns have a variance less than 1%, then it's gonna be removed. All right, so 0.1. That's mean 99%. 1% is going to be removed. All right. Then after that, what I'm gonna do here, I'm going to do this transformation on the training data set. All right, so here we have a filter dot the fit underscore transform and x underscore train. We need to fit it on only the training data set, and on the testing data set we need to only transform. Otherwise our model will be overfitting prone. So here x underscore test is equal to filter dot transform. Do remember here I am doing here a transform, not fit transform. So I'm just transforming it based on the features calculated from a training data set. All right, so here we have X test. Now let's go ahead and see a save of these training and the testing data set. So here we have X train dot save and similarly X test dot save. Now we should see here the decreased save. Earlier we had 369 features, but you now see here we have currently just 273 features. So there are total 369 minus 273. There are total 116 features were removed. All right, from this. All right, so we have removed here constants and quasi-constant features. Now let's go ahead remove a duplicate features as well. To removing a duplicate features, we need to first transpose our data set. Since we don't have any direct functions to remove a duplicate features, but we have some functions which can actually remove rows. So what we are going to do with the transpose, we are going to convert these columns into a rows, and then we will find any duplicate. Okay, if there are any duplicate into a rows which was earlier a column, then we are going to drop those, and then again we will transpose it. All right, so how we can do that? We are going to just call it X underscore train underscore T is equal to X underscore train dot T. Okay, and then after that we have here X underscore test underscore T. That's mean the transpose of the test data set. Then here we have X underscore test then dot T. All right, so now we have a transpose data set. Let's go ahead and convert these data set into a pandas data frame, which we can do by calling X underscore the train T is equal to PD dot data frame. PD dot data frame. And then after that we have here X underscore the train T. All right, and apart from that we have here X underscore test T is equal to the PD dot data frame, and there we have X test T as well. So we have converted it into a pandas data frame. Now let's go ahead and see a save of this data set. So X train underscore T dot save. All right, now you see here the columns has been converted into a rows and the rows has been converted into a column. All right, now we can apply here a duplicated features. So let's go ahead and see how many duplicate features are there. So the pandas have attribute there a duplicate which we can apply here. X underscore train underscore T dot duplicated. All right, so this will say that how many features are duplicated. Let's go ahead and see if there are features which are duplicated. All right, just wait for a few seconds, so it might take a little time, but in meantime let's go ahead and add a few code cell. So all right, so there are total 17 features are duplicated which we actually need to remove. So let's go ahead and get the list of the duplicated features which are duplicated. We can get that with the duplicated underscore the features. So these are the duplicated underscore features is equal to X underscore train underscore T dot duplicated. All right, now let's go ahead and see here the duplicate features. So once you print this, you will get something like a Boolean values, true and the false. So it will represent that those values which are true, that's mean those values are duplicated, and the values which are false, that's mean those values are not duplicated. All right, so if it says that it is a true, that's mean the value at the index of the 254 is duplicated with some other value. All right, so let's go ahead and now so here the true value shows that these features are duplicated, but we want to keep non-duplicated features. That's mean these false values we want to keep. So for that we need to do an inversion here. So let's go ahead and do an inversion. All right, so here we can say features to keep is equal to, there is going to be a list. In that I'm going to call here not index for index in duplicated features. So with this we have inverted it. All right, so we have inverted. Now the true has become a false and the false has become a true. All right, so with this now we are going to say that these are the features which we are going to keep, and the false are those features which we are going to drop. All right, so let's go ahead and keep the only unique features, and to do that we are going to create a new variable here, x train underscore unique. Otherwise just I'm going to keep those into x underscore train, and then here we have x underscore train t, and in that I'm going to pass here features to keep, and after that I'm again going to transform it, so that earlier we had made rows as a column as a rows, but now I'm going again transpose it, so that now the data should become into a true form. So let's go ahead and now see a shape of this train. Now we see here the shape of train has become again the row has been converted into the column and the column into rows, so it's came back into original shape, although the constants, quasi constants and the duplicated features has been removed. The total number of features you see here are from 369 to 256. All right, so these actually the pre-processing helps us to improve the accuracy of our model. All right, so let's go ahead and do the same things with the testing data set as well. So for that we can do x underscore test is equal to x underscore test t, and then here we have the features which we want to keep, and then again we are going to transpose it. Let's go ahead and see a shape of x test as well. We should get a same shape. All right, so you see here, so there are 60,816 rows in a training data set and 15,204 rows into a testing data set. All right, so let's go ahead and print here a training data set, which we can do with x underscore train, and you print it. Once you print it, you see here this training data set is having a lot of the variance between the columns. So these variants should not be there, otherwise our machine learning algorithm would not be able to learn it perfectly. So we need to apply here, let's go ahead make it head. So we need to apply here a standardization technique. So standardization is a technique which brings the standard deviation of all rows into a same scale, and that is actually very essential part of machine learning model regularization as well. So we can do that. We can just call here a scalar is equal to standard scalar, and there we have x underscore a train is equal to scalar dot fit. All right, underscore transform. So you see here this scalar is going to standardize this first x train data set, so that we can say here x underscore train, and similarly it is going to standardize the testing data set as well. But do remember, we are not going to apply a fit transform, but instead of fit transforms we are going to apply just transform. So x underscore test. All right, now you see here x underscore train, it has this standardization has brought down all these columns into a same range. That means the standard deviation or variance of these columns are almost in a same range. So these techniques actually helps to improve a machine learning model. All right, so it means it actually make an accurate model. All right, so we have now our training and the testing data set. Let's go ahead and see the shape of again the training and the testing data set. X underscore the test dot shape. You see here a shape which currently we are having. is 60,816 by 256. But in neural network we need to pass, and if you see the first row is just having a 256 columns. So in a neural network, what we need to do during a fit, it accepts the 3-dimensional data. So we need to also reshape this. To reshape, what we can do, x train is equal to x underscore train and then dot reshape. And during the reshape, what we are going to do here, a 60,816 cross 256 and cross 1. Alright, so the data we are not changing, just we are reshaping it to fit on our convolutional neural network. Alright, so we need to reshape it. Again, it has 15,204 rows and 256 columns, and of course 1 dimension in 3 dimension. Alright, so now we have got it reshaped. Let's go ahead and paste it here and see now the dimensions. So here it has become a 3-dimensional data. Now we are ready to pass it into our model. But before that, we need to also convert our y. If you print here y is actually a series. Alright, so if y is a series, then y train is also a series. So we need to convert actually this y train and the test in a NumPy array. So here we have y underscore train, then dot 2 and NumPy. Alright, so similarly we need to do for testing as well. Y underscore test is equal to y underscore test, then dot 2 NumPy. So here we have our NumPy array for x as well as, the feature space and a target space as well. So this is ready to pass into our neural network. But before that, we need to build our neural network. So let's go ahead and build our neural network. Let's go ahead and first add few cells here. And those cells we are going to, okay, so we have here enough space. Let's go ahead and first get a sequential model. A model is equal to sequential. And after that, we are going to add a first convolutional layer in this, which we can add with model.add and then conv1d. Alright, so here we have convolutional 1D, and in conv1d you see the first parameter is filter. So filter, I'm going to pass here 32 filter a first time, and then after that the kernel size, it is asking about kernel size. I'm going to pass here a 3 kernel size, and then it is asking about activation function. So activation function is, I'm going to pass here a ReLU, and it is rectifier linear unit. And every time when you are passing, when you are building a convolutional neural network, then you need to pass input shape in a first layer, which we can do with input underscore shape is equal to, you see here what is the shape, current shape is 256 and 1. All right, so here we have a 256 cross 1. So this is the input shape of 1-dimensional vector. And apart from that, now I'm going to add a batch normalization. Batch normalization make a faster training. So here we have a batch normalization, and after batch normalization, I'm gonna add here a dropout. All right, so instead of a dropout, I'm also going to add here a max pool as well. So here I'm going to add a max pool. So here we are going to do a max pool 1D, and the pool size I'm going to pass here 2. All right, and after that I'm going to add here a dropout. So here we have a dropout. I'm going to add a 50% dropout in very first. Instead of 50, I'm going to add here 3% of a dropout. 30% of a neural network, neurons will be dropped randomly in a first layer, after a first layer, while passing input to a second layer. Now let's go ahead and train it into a model let's go ahead and add another layer of convolutional neural network, which we can actually copy from here, and we can simply paste it here. But this is hidden layer, input layers. So internal layers, we can remove this input shape. We don't need that. Now let's go ahead and change this filter size to 64, and kernel size we are gonna keep a 3. batch normalizations, and dropout I'm going to increase it from 30% to 50%. All right, so let's go ahead and add here a third layer of convolutional neural network. In that, I'm going to pass here 128 units, and other parameters will be the same. All right, so these are the 3 layers of convolutional neural network. After that, I'm going to flatten this 2-dimensional data, which we can do by calling model.add and then flatten. All right, so this is a flattening layer which converts the 2-dimensional or 3-dimensional data into a single dimension. All right, into actually a vector. So after that, I'm going to add here a fully connected layer, which is actually a dense layer. And in this dense layer, I'm going to pass here 256 units, and activation functions will be ReLU. And then I'm also going to add here a dropout. All right, so here we have 50% of a dropout as well. Apart from that, let's go ahead and add a final output layer. So we only need to predict either 0 or 1, whether customer is going to stay with the bank or not. That's mean it takes just a single unit in our dense layer. So it will have just a single unit. And since this is a binary classification, that's mean the activation function will be used as a sigmoid. All right, so with this, we have built our model. Let's go ahead and run this cell. We have our model. Now let's go ahead and print a summary of our model. So here we have a summary of our model, and now you see it has more than 1 million of parameters while calculate. That's mean it is going to take a lot of the time during the training. All right, so let's go ahead and do first a model compilation, which we can do with model.compile. And then we can pass here the optimizer, which we are going to use. We are going to use here ADAM optimizer. All right, so in fact we are going to use ADAM optimizer with 0.001 learning rate. So here we have ADAM optimizer, and we are going to pass a learning rate as well. Learning rate I'm going to pass here 0.00005. So that is actually the too low learning rate. And after that, I'm going to pass here a loss function, and the loss function, since this is at the bi-class classification, I mean the 2-class binary class actually. So we are going to use here binary cross entropy. All right, so here we have a binary and then cross entropy. And apart from that, here we are going to pass here the metrics. That's mean on which metrics this will be evaluated, and that matrix is accuracy actually. So here model compilation has been done, but it says that we don't have ADAM. So let's go ahead and first import ADAM from optimizer, which we can do here. In fact, we are going to do that here from TensorFlow .keras and then .optimizers. Import ADAM. So let's go ahead and run this. Sorry, perhaps here we have wrong it. Yes, this is wrong actually. We should have it TensorFlow. All right, so we have imported ADAM optimizer. Now let's go ahead and compile our model. So this compiles our model. Now we have reached into a most exciting state, which is a model training. All right, so history of model training, that will be recorded into a history. That's mean the loss and the accuracy of a step-by-step model. So here we have a model.fit, and after that we are going to pass here a training and testing data set. So we pass here x train, y train, and the batch size we are going to leave the batch size. But apart from that, here I'm going to pass here epochs. I'm going to train it for the 10 epochs, and apart from that, I'm going to also pass here validation data, so that during the training it can also validate and fine tune weights of a neural network, which we can do with x test and then y underscore test. All right, and the verbose which I'm going to pass here 1, that means it should print the progress of a training. All right, so it has started training, and the initial accuracy is the 92% actually, or 93% in fact. But now you see here at the very first step we have crossed this the leaderboard actually. You see the accuracy of leaderboard is just 82% and 84%. So in very first step we have crossed and we have passed that accuracy. Now you can understand this is the power of convolutional neural network and feature selections together. So with the feature selections, what we did actually, we had removed unnecessary features which was actually not giving any importance in final predictions, like a constants, quasi constants, and the duplicate features. By removing those features, we have reduced complexity of models and the chances of overfitting. All right, so let's go ahead and wait for some time to get it trained, and then we will start this lesson again. All right, training has been completed here, and you see we have been getting accuracy of a 96% almost. That is the training, and validation accuracy is almost the same here. That means we can say that our model is neither overfitting and nor it is underfitting. All right, so we have trained it for 10 epochs, and now the time is to plot its learning curve and see how loss is decreasing and how training accuracy is increasing. And apart from that, if you see here our accuracy, validation accuracy, which is around 96%, and if you compare this accuracy with the people who have submitted their the task at Kaggle, so the public leaderboard, the highest accuracy is in 84%. So with these techniques, you can achieve a 96% accuracy, which is far better than this current accuracy. All right, so let's go ahead and see what we have inside a history. To do that, what we can do, we can just type here a history. All right, so this is actually a dictionary which returns you accuracy, loss. This is for a training set, and validation accuracy and validation loss for validation set. All right, so I have already written a function for this because I have been covering this learning plot since so many videos. So you can go ahead and watch these videos as well to see how we need to plot, how we can actually plot this learning curve. I have already written the code. I am just going to copy and paste it here, and I'll explain you what is happening here. So this is a method. All right, so this is a method, and you see here a history.history and accuracy key. This represents a training set accuracy, and this represents a validation set accuracy. So these we are going to plot in one figure, and these we are going to plot in another figure, and that figure is for a loss. So the first line is for the training loss, and the second line is for a validation loss. All right, so let's go ahead and plot learning curve. Call this plot learning curve. So we can call this. Now we need to pass here. Sorry. Now we need to pass here a history, and then we have trained it for 10 epochs. So let's go ahead and pass here a 10 epoch and hit the enter. Now you will see here we have got a perfect learning curve. So in this you see after 8 or 9 epochs, training validation accuracy decreases, but training accuracy was almost the same, and similarly it happens here. So in this way you can say that we need to train our model around 6 to 7 epochs, and after that we will get a perfect model which can achieve around 96% of accuracy. All right, you see here. So this is a maximum accuracy which we have currently, 96.05% of accuracy. All right, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and subscribe this channel, and if you want a video on any other topics, please comment below, and I'll definitely try to make that video. Bye bye, have a nice day.